Now, this lesson particularly ties into what we just did, and it's in a different chapter. And once we finish this, we'll be moving into our regular chapters, doing lots of topics from them. But to complete our background information, we're doing section 8 of chapter 4 here, the Pythagorean Theorem. And you'd, of course, want to write that in your notes so you know what we're talking about. So our basic objective here is to understand the Pythagorean Theorem. So, in your notes, I would sketch a right triangle, the area in blue here. And as we define it, there is a right angle. Right angles are 90 degrees, something you should know. And then usually, but not always, there's a short side, which we call a leg, and then a long side, which we call another leg, that is adjacent, that is next to, the right angle. So you have the right angle, a short leg, a long leg. Now, the side opposite the right angle is this long side here. The official name for it is the hypotenuse. Now, when I would teach this in earlier lessons here, I would often refer to the short leg as side A, the long leg as side B, and the hypotenuse as side C. And we'll be using these letters too. So we then say A squared, if you square the length of this side, and square the length of your long leg, that is equal to the square of the hypotenuse. And there, in a shortened form, and you'll see this used throughout the rest of the slides, is the Pythagorean theorem. Now, knowing this relationship, we can do a lot of figuring, which is what we're going to be doing. So, once again, they're labeling it a little differently, but that's okay. I prefer the short leg A and the long leg B, but that's okay. It's just one of the legs and the other leg. So if we square those legs, add them together, that'll give us C squared. So we can use this by manipulation a little bit to find out if there's a missing leg. And one of the things they ask us is to prove if something is in fact a right triangle. We want to know, is this angle right over here, is this a right angle? Now, in order for this to be a right angle, the square of this side and the square of this side would have to equal the square of that side. So let's do that. So if we square the 3, we get a 9. Square the 4, we get a 16. 9 plus 16 is 25. If we square 5, we get 25. So the square of the sides, the sum of the sides, equals the square of the hypotenuse. So this is true, and we have a right triangle. And this is one of the most famous right triangles. We call it the 3, 4, 5 right triangle, because this is such a beautiful example. Now, in this case, we're going to use a calculator and the knowledge of the Pythagorean theorem to find the length of the hypotenuse, accurate to a nearest hundredth, of a right triangle whose legs, short leg in this case, is 1, and long leg is 3. So generally I suggest you make a little picture of this, as they show here. And it doesn't necessarily have to be proportionate, but it gives you an idea of what you want to find. So there's your short leg, there's your long leg. So they're squaring the short leg, squaring the long leg. 1 squared is 1, 3 squared is 9, 1 plus 9 is 10. Now, you have c squared, the hypotenuse, equal to 10. How are you going to find what the square root? Well, you have to take the square root of both sides, as they're going to show you here. That would be the square root of c squared is c, and now you take the square root of 10. This is from our previous lesson. And putting that into your calculator, rounding it to 2 decimal places, you get this. Now, of course, you're going to have to try this on your calculator. You want a strategy that when you're taking a test, you're not able to use your notes, so you have to make a little picture, remember the Pythagorean theorem, and get your answer. Now, this could be a quiz question, where if you have it worked out in your notes, you already know if this were the triangle I gave you. All right, now we're going to use a calculator again, but now we know the hypotenuse is 20, and one of the legs is 13. We want to find the missing leg. So once again, a picture is going to be useful. There's your hypotenuse is 20. One of the legs is 13. You want to find the missing leg. So you set it up. The missing leg is x squared. We have to square this. We're going to square the 13. And we're going to square the hypotenuse, 20. And that gives us this. Now we still want to find out what x squared is, and eventually the x. So in solving something like this, we subtract the 169 from both sides. They'll show you that here. So on this side, it becomes 0 here. And when we do this subtraction, it becomes 231. So we still now have x squared. Well, we're going to take the square root of x squared to get x, and then the square root of 231 that we put in your calculator. And when you do so, rounding it to 2 decimal places, you get this. Now, this is the exact answer, but when we approximate by rounding off, we use the wavy equal sign, which is approximate sign. Now, sometimes they'll give you a word problem. A guide wire is attached to the top of a telephone pole and anchored to the ground 20 feet from the base. If the pole is 40 feet high, what is the length of the guide wire? So again, a picture would be useful here. And I see they're not giving us one, so I'll give you one. Now, as we look at this, there is your telephone pole, and we said that was 40 feet high. The blue line is your guide wire, and we're going to call that X. And we say the guide wire is 20 feet staked out from the telephone pole, so this is 20 down here. So again, they're just asking this in the form of a word problem, which we'll have throughout our lessons. And a picture, I think, is helpful. So, we don't know what this is. We're going to square that. We're going to square this side, and we're going to square this side. So it's basically x squared equals, using the Pythagorean theorem, 20 squared plus 40 squared. So that's where this formula comes from. And I thought they would give us a diagram, but they didn't here. So now we go to our next stage and do the calculation of this. So 20 squared is 400. 40 squared is 1600. We add the two together and we get 2000. Now we take the square root of x squared, which is x, and the square root of 2000. Put this in our calculator, and we find that the guide rope is, or guideline is about 44.7, depending how they ask us to round off. And that completes this.